students, this is Satyanarayana, Physics. Already you have learned the Physical Sciences first lesson, that is motion lesson part 1, isn't it? Now you will learn the motion lesson part 2. In the next part, here part 2, in the first part you have learned about the speed, velocity. Now you will learn about the uniform and non-uniform motions. That means after this end of this activity or lesson, you can easily say about the uniform, what is a uniform motion and what is a non-uniform motion. Understood? Okay. Now I will continue with the uniform and non-uniform motions. So any object which moves with a constant velocity is uniform. That means if it covers equal distances in equal intervals of time, then it is under uniform motion. Okay, that means unequal changes in equal intervals of time, then it is non-uniform motion. Okay, how can you identify when you are given a graph? Okay, here if you observe the three straight lines, the three lines, okay, two of them are moving from the origin and making an angle theta and moving in a straight lines, but the third one is moving in different directions. That means three straight lines where time is on the x-axis and distances are measured in the y-axis. If I ask you which one are uniform, that means in which lines there are equal changes, then you can easily say the orange and the brown color are the straight lines which are moving in a equal changes in equal intervals of time. That means these two are under uniform motion, and the third one, a green one, which is under non-uniform motion, which covers unequal changes in equal intervals of time. Okay. Then if you take any object, okay, which is moved in an inclined plane, observing the motion on inclined plane, okay, for that you require a steel plate or a steel scale, okay, making an angle theta with the surface or the ground, okay, kept it on a stack. Okay, so here this steel plate acts like an inclined plane. Take a marble and it allows them to drop from the top. Okay, it goes down, and if you observe their speeds, okay, initially it goes slowly and speed increases slowly after reaching the ground. Okay, but here speed increases gradually and direction always in one direction, that is constant. Okay, so here you can observe one more example. As the ball goes down, if you apply a force, it moves upward also. Okay, initially with if the ball goes upwards with okay, greater speed initially and the speed decreases slowly. So we will observe one more, okay, motion on an inclined plane. So that means speed increases gradually and direction of motion remains constant while it is going down. Okay, while coming up, the speed decreases gradually, but the direction of motion remains constant in opposite direction. Now, what is a uniform circular motion? Any object which moves follows a circular path, then we say the body is under circular motion. That means a car moving around a circular park, or the movement of the planets around the sun. Okay, so here what is a uniform circular motion? The circular motion you already understood in the lower classes. The same, but if it covers equal angles, in equal intervals of time, that means angular speed. Okay, that means speed remains constant, and the direction of velocity already you learned in the first part. How can you draw the direction of velocities? By drawing the velocity vectors, or a perpendicular line at that point gives the direction of velocity. Have you understood what is uniform circular motion? Here what remains constant? Speed remains constant, and direction of velocity changes continuously. So what is an example? A wheelstone. What is a wheelstone? Simply take a stone and tie to an thread. Okay, and take the edge of the thread and try to rotate. Okay, if you leave that thread support, then it moves not in the straight line direction, it moves in the tangential direction. For example, a person who is on the earth, suddenly the gravity disappears, he will not go straight away upwards, he will go in the tangential direction of the rotation of the earth. Okay, that is uniform circular motion. Now, in another example for uniform non-uniform motion. Okay, then for example, when a body is thrown into the air, for suppose a fielder who is on the boundary line and throwing the ball to the wicket keeper, that means here speed changes continuously, and also direction of velocity also changes continuously. Both speed and direction changes continuously is an example for the non-uniform motion. That means a ball thrown into the air is an example for non-uniform motion. One more examples we'll take. Okay, so what you have learned, what is a non-uniform motion? With unequal changes in equal intervals of time, then or else equal distances in unequal intervals of time, or the speed constant but direction changes continuously, then we say the body is under non-uniform motion. Say one ball moves uniform motion, another one also moves in uniform motion, but you observe the middle one, it moves in non-uniform motion. Understood? So in this motion lesson, what you have learned till now, you have learned about the uniform motion, non-uniform motion, and uniform circular motion. Just once revise. Okay children, have you understood this part? Very good. So we'll continue the next part in the next class. Thank you.